Hi all, today we are going to continue discussing on Chapter 3, Current Flow in Homogeneous Semiconductor. We are going to focus on generation and recombination. We have learned that the current in a semiconductor is a result from moving particles, namely electrons and holes. In order to conduct current, electrons must be at the conduction band and holes at the valence band. We also have learned that when the temperature is very low, the electrons are mostly at the valence band. At room temperature, some electrons will have energy to jump from valence band to the conduction band. So, electrons must have energy, for example, thermal or optical energy, in order to jump, or we call it excited, from valence band to conduction band. And the electrons at the conduction band after some time will go down, or we call it relax, from conduction band to valence band. So in this video, we are going to discuss on the processes of electrons excitation and relaxation, and at the end of this video, I hope you will be able to explain the generation and recombination process in semiconductor. Let's see what happens at equilibrium. We have learned that at equilibrium condition, for example, an intrinsic semiconductor or a uniformly doped semiconductor at room temperature without any light, there will be electrons that are excited from the valence band to conduction band, and electrons that relaxed from conduction band to valence band. But the excitation rate and recombination rate are the same, which means the number of electrons that jump to conduction band and number of electrons that fall to valence band are the same. This will result in constant N node and P node. But most of the time, our semiconductor devices do not operate under equilibrium conditions. Thus, the total number of electron concentration N is not equal to N node and P is not equal to P node. Thus, we need to understand the generation and recombination process. Generation is a process of electrons being excited and moved from valence band to conduction band. So, when the electrons leave valence band to jump to the conduction band, it will leave an empty space or holes at the valence band. Thus, generation, by definition, is the process of electron excitation from valence band to conduction band, creating electron and hole pairs. On the other hand, recombination is a process where electrons at the conduction band return to the valence band. When this happens, the holes at the valence band disappear. Thus, by definition, recombination is a process where an electron from conduction band is relaxed to valence band, thus annihilating an electron and hole pair. There are two types of generation and recombination. One, band-to-band generation and recombination, and two, the two-step process. First, we'll take a look at band-to-band generation and recombination. For the generation, as can be seen in figure 3.12a, generation happens when there are photon and phonon energies that are absorbed by the electrons at the valence band. If the energy is larger than the band gap, then the electrons can jump to the conduction band and creates electron and hole pair. Let me explain further. Let's look at these examples. In case 1, if the given energy is smaller than the material's band gap, then the electron will be excited halfway, depending to the energy they receive, but will fall back to the valence band before reaching to the conduction band. This is because there is no sites for the electrons to stay at the middle of the energy gap, as we have learned in Chapter 2. In this case, we define that the generation process does not happen. For case 2, in this case, the energy given is larger than the energy gap. Thus, the electron will have sufficient energy to jump from valence band to the conduction band and stay at the conduction band for some time, and leave hole behind in the valence band. We define this as generation process. So, in short, the electrons will need energy larger than the band gap in order for the generation to happen. The energy can be in the form of photon, phonon, or combination of both. Recombination process is simpler. After some time being at the conduction band, the electrons will fall down again to the valence band. When this happens, the electrons that relax to the valence band will release or emit energy larger or the same as the band gap. The energy is emitted in the form of phonon, or some materials release the energy in the form of photon or light. When recombination happens, electron and hole pair will disappear. Another type of generation and recombination process is two-step process. In band-to-band process, the electrons jump directly from valence band to conduction band or relax from conduction band to valence band without stopping in the forbidden gap. In the two-step process, it is different. The first type of two-step process involves dopant states. We have learned in Chapter 2, in doped material, we will have acceptor states for p-type material and donor state for n-type material in the forbidden gap. In this case, for example shown here, when the electrons receive phonon energy, they will be excited to the acceptor state in the forbidden gap and temporarily stay there. When there is photon, then they will absorb enough energy to jump to conduction band from the acceptor state. This will create electron and hole pairs and defined as generation. In recombinations, the electrons relaxed from the conduction band to the acceptor level in which photon will be emitted, and then, after temporarily being in the forbidden gap, the electron further relaxed to the valence band and recombine with holes there, making an electron and hole pair disappear, of which this is recombination process. Another type of two-step process involves trap states. Some materials may have trap states in the forbidden gap that may be due to crystal defects. These trap states or trap levels will temporarily trap the electrons either during the generation or recombination process. The generation and recombination process in this type of material is similar to those that we have explained with the donor states before. To summarize, in general, electrons need energy that is the same or larger than the band gap in order for generation to happen. The energy can be in the form of photons, phonon, or combination of both. There are two types of generation and recombination. One is band-to-band and another one is two-step process. And at equilibrium, generation rate and recombination rate are equal. So that's all for now. Please do not hesitate to ask questions and discuss on this topic via WhatsApp or at the comment section in the FB post of our ELE 541 FB group. Thank you.